I, Ryutaro Watanabe of the Graduate School of the University of Tokyo, will now begin my presentation. The title is Redirection Detection Thresholds for Avatar Manipulation with Different Body Parts. Humans use various parts of their bodies to provide motion input for operating devices and machines in our daily lives. While hands are most commonly employed for this purpose, other body parts are also effectively utilized depending on the situation. For example, driving a car involves using hands to control the steering wheel and buttons, while a few feet manage the car's acceleration and braking. So designing interfaces tailored to the specific body part has the potential to offer optimal performance and interaction in both real-world and virtual environments. One crucial design element is how to map user motor inputs to the corresponding operations. Various interactions can be achieved depending on the mapping methods, a technique often referred to as redirection, remapping, or retargeting. For example, by shifting the virtual objects or avatar's movements in response to the user's actual movements, it is possible to effectively utilize real objects in virtual reality and support intuitive control of robotic arms in the real world. Such redirection techniques are based on the effect of visual dominance, where visual information takes precedence while integrating and processing multiple sensory inputs. However, if the discrepancy between visual information and other sensory inputs such as proprioception becomes significant, this discrepancy can no longer be ignored, leading to a sense of discomfort for the user. Therefore, understanding the stressful limits for the directions that avoid such conflicts is crucial for designing systems, and many researchers have been investigating these limitations. In addition, the previous study of Ogawa et al. Have found that the closer the operating avatar to the shape of the hand, the less likely it is to be noticed by redirection. However, it is not yet clear whether this principle applies when the avatar is manipulated with the feet. So the purpose of this study is to identify the factors that affect the redirection threshold during redirection when manipulating by feet. In order to achieve this purpose, we investigated the detection threshold at the time of redirection when performing an operation using a foot. Additionally, we evaluated the effect of the appearance of the object on the detection threshold or redirection when a foot is used for manipulation. I will then describe the experiment we performed. First, there's a disposition of objects and the vertical offset. The wheel scene for the task was arranged with a panel with the initial object, which is a spherical object in the foreground, the target object, which is a spherical object in the background, and the question text. The target object was set 0.2 meter farther and 0.05 meter lower than the initial object. The initial object and the target object was the same appearance. Both objects were 0.05 meter in diameter and wide in appearance. The distances were determined based on preliminary experiments so that the seated participants could touch both the initial object and the target object. In addition to that, the wheel avatar operated by the participants as a group of objects in the wheel scene were placed so that they were at the same height as the eye level according to the offset model. We used this offset model to eliminate the visual effects caused by differences in the avatar's vertical position and to standardize the visual conditions between hand-operated and foot-operated conditions. Second, this is the redirection model we have adopted. Redirection was not performed until the initial object and was performed from initial object to target object linearly. This redirection was applied to the right or left as the avatar moves further back. And this is the illustration of the trial process of reaching task. Participants first touched the initial object and waited for 1 second. After that, they touched the target object in 1 second and moved back the avatar to the initial object. While the phase 4 to 6, the redirection was applied to the avatar. After the trial, participants answered the question on the panel. The following question was presented in Japanese on the question panel. Did the movement of the real hand, the spear, correspond accurately to the movement of your actual body? This is a demonstration of the trial process. The video on the left is in real world and on the right is in the virtual world. Finally, we describe the conditions of the experiment. The first condition is the body part to be manipulated. We compared the case where the manipulation was performed with the right hand, right foot, and left foot. Note that the left hand was not included in the experimental conditions because we operated the controller with the left hand. The second condition is the appearance of the avatar. We prepared avatars with the abstract appearance of the sphere and the appearance of a hand. Finally, the direction of redirection. This time we defined the direction conditions as medially and laterally. Therefore, it should be noted that if the avatar is manipulated with the right hand or right foot, the medially is on the left side. But if the avatar is manipulated with the left foot, the medially is on the right side. So I'm going to the results section. The bar graph on the left plots the results separately by condition, which reveals three major facts became apparent. First, it could not be said that there was a difference in the redirection threshold between different body parts. Second, the redirection threshold was 21% higher when using realistic avatars than when using abstract avatars. Finally, the redirection threshold was 49% higher for medially redirection than for laterally redirection. The effect of avatar appearance on detection threshold was consistent with the previous studies mentioned earlier. The fact that the detection threshold was greater for the hand avatar even when manipulated with the feet suggests that the detection threshold may be independent of whether the appearance of the manipulated object resembles the manipulated body part. Next, we would like to discuss the impact of redirection direction on detection thresholds. Assumptions: the increase in detection thresholds when redirected in the medial direction is generally consistent with trends observed in several previous studies. In other words, when the avatar is manipulated with the right hand, the redirection threshold is almost universally larger for medially redirection. There are several possible reasons for that. The first cause is the correction and extension of the body part. As shown in the figure on the right, when mapping laterally, the body must be moved medially to compensate for the misalignment, so the elbow tends to be extended. This discomfort may affect visual dominance and detection thresholds. The second cause is peripersonal space, or the space near the body. Prior research has shown that characteristics of peripersonal space differ from those of the space lateral to it. Also, for example, in the rubber hand illusion, it has been suggested that the illusion weakens when the dummy hand is farther from the body's midline. From this, the avatar's authenticity may have been compromised by the lateral redirection of the avatar out of the peripersonal space. I will now summarize what has been said so far in described future works. First, the detection threshold of realistic avatar was higher. Second, the detection threshold for medially redirection was higher. Body structure in the peripersonal space are possible causes for this. Finally, there was no difference in the detection threshold between the case where the operation was performed using the hood or the hand. And in the future, the limits of the application of redirection exercises other than reaching tasks need to be investigated. That concludes our presentation. Thank you for your attention.